فليتفضل الدكتور قاري ليحدثنا حول نظام تزويد الهواء النقي في أجهزة التنفس لرجال الأطفاء في المباني الشاهقة. Please.
Good morning, and thank you. It's a pleasure to be here. Thank you for the invitation to come to your conference in this beautiful city. The theme of the conference is technology and innovation. What I'm going to present to you is a means to use technology that will put firefighters into the firefight earlier and be able to sustain that firefight longer. And that system is called the Firefighter Air Replenishment System. It goes by the acronym of FARS. So it began with a number of fires in the U.S. 1988 was one of the first that recognized the problem of air supply to firefighters. As you will see in the slide, 383 firefighters tackled this fire, and they consumed 600 air cylinders. All those cylinders had to be transported manually to a location in the building to resupply firefighters fighting the fire on the upper floor. So, what's the problem? The problem is moving 600 cylinders to an elevated location within the building is antiquated. It takes an awful lot of firefighters to do that. The chief from Chicago had a slide of a little hand cart with probably a couple dozen cylinders on it. It's time consuming. It consumes a lot of firefighter manpower on the scene. It takes firefighters from the firefight to support air supply. What this system does is move firefighters directly from that, eliminates the need to transport air cylinders to the interior of the building. Here's what it is. Very simple. 100 years ago, we were having trouble as firefighters getting hose lines up to upper floors. We mandated and installed standpipe systems, wet standpipe systems. The principle of FARS is no different than the water supply going into a high-rise building. You put in an internal plumbing system to provide air to firefighters on the upper floor. The slide to the left is the connection station at the exterior, and the slide to the right is rapid refill on a fire floor or somewhere in the stairwell. As I said, this is not any different than the standpipe system we use today to supply water. What we're doing with FARS is supplying air. Some of the first innovators of FARS are listed there. My experience with the air replenishment system started when I was the fire marshal with the Phoenix Fire Department about 12 or 15 years ago, when the company came to town, made a demonstration. It was quickly recognized how efficient this is to firefighting in high-rise, and we were able to convince a building that was about to be constructed to install the system as a prototype. That system was completed, the building was opened, the fire department did quite a bit of training on that and determined that, one, the system is very efficient, eliminates transporting cylinders, but it had only been installed in one stairwell. And as a result of the training and fire experience, it is recognized that the access to that air supply is going to be determined by the location of the fire. So we codified fire code that required the standpipe air supply system in two separate stairwells opposite sides of the building. Presently in Phoenix, 42 high-rise buildings and mid-rise buildings have the system installed, and they work very well. But it's not limited to just high-rise. You've got several other large buildings that the system can be used in, and we'll talk about large warehouses in a moment. Quite a bit of support in the fire service industry to the system. Not only does it provide efficient means to keep firefighters supplied with air and continued work on the firefight, but it reduces their exposure to smoke environment as well. This is a 5/8" stainless steel, high quality air supply line. We have a problem with friction in moving water through a standpipe. We have very little problem moving high pressure air through a small channel. This is hardline steel, almost indestructible. Okay. On-site storage systems, virtually all these have an on-site storage system. The reason is you need an immediate backup air supply to resupply air to that first wave of firefighters that are using up that first cylinder. So this has the ability to maintain filling 200 cylinders, allowing enough time for a compressor vehicle to arrive on scene and connect into the air standpipe system. So the first firefighters up on the floor will immediately have a means to go to the stairwell in one of these rapid refill locations and refill their bottles in 2 minutes time and then return to the firefight. It's just a sample of a cascade system in Highrise at a particular location, generally down at floor level because it's easier to maintain maintenance on it. You have a standardized connection, and that's the standardized connection area. You got different kinds of connections there depending on what you're using within your community. You got some exterior from the building refill stations, the same as this. It's right here, so you can pull right up at curbside. It's pre-plumbed into the building, or you can go right up against the building. This vehicle is a Phoenix Fire Department air compressor unit. The city has 5 of those. It has a 200-foot cord to connect into the system. Okay, it has an air monitoring system, so pressure is constantly monitored. Moisture is constantly monitored. Contamination is constantly monitored. And if any one of those have a deviation, you have an alert down at the command facility within the building that something's amiss. Secondly, it's monthly tested under NFPA standards for air quality and contamination. So it's a good system. It's pretty much tamper-proof, guaranteed to have good air for your firefighters. So if any one of those 3 major factors are corrupted, you get a signal down at the panel, and for some buildings, if they desire, they have an audible alarm as well as a strobe light indicating there's some kind of failure within the air supply system. Insulation vials, and this is something that probably needs to be adapted to water standpipes as well. That if for some reason above you that line is ruptured, currently in a standpipe system, water standpipe system, you're going to lose your water. These are 2 valves. This can be radio activated to close and open, and the backup is manual. So for some reason, such as a terrorist attack, and you've got a plane into the building or a detonation that's damaged the system above, you can have these every 2 or 3 floors, and you're still going to have the ability to return to an area below that valve and still have air supply. It's a wonderful backup. There's 2 methods of resupply. Some departments, especially years ago, preferred to have a containment system, concerned about a rupture on rapid refill. Well, over the last 2 decades, I have no knowledge of a breathing apparatus on a firefighter getting rapid refilled rupturing. The 2, Phoenix Fire Department and Seattle Fire Department, where I was chief, both now rapid refill firefighter bottles while they're still wearing the units. But you had this ability, and they can do 2 at a time. It'll refill that cylinder in about 2 minutes time, but you've got an extra 3 or 5 minutes of manually messing with it in order to get the bottle refilled. The other method is the rapid refill station. The typical staffing on most fire departments in the metropolitan area in the States is 4 members, so they have 4 outlets. So you can hook up 4 guys if you can get them in there crowded at the same time. And again, once that connection is made, 2 minutes later, your bottle is topped off. And here's an example of a location. It's in a locked box that can either be opened by a key or easily forced by firefighters. You know, firefighters always like to damage things. They tear things apart at times. But this is an example of a location, and these locations are dependent on building code and building desires, but at maximum every 3 floors. Some buildings require it every 2 floors, but if you have it every 3 floors, there's no more than 1 floor up or 1 floor down for a firefighter to reach the station. And this is the example of the cascade system, I believe. Okay, as I mentioned, it's not restricted to just elevated locations. Everybody has a big box warehouse, 100,000, 200,000, 500,000 square foot of storage. These are pedestals, 2-hour rated. The air supply is underground, protected. So for a firefighter that's out here 300 feet, 100 meters into the building or greater, it may be more efficient to go to one of these pedestals that has a strobe going so they can find the location quickly and refill their bottle. Tunnels, train stations, same application. The pedestal located, and in some cases, if you want to put it in the tube between stations, you could do so. There's no cost to the fire department other than an investment in a compressor unit if you don't already have one. All the burden is put on the builder, owner, okay? No new fire department equipment required. And it costs less than 1/2 of 1% of construction costs to include this in the building, construction of the building. Retrofit is pretty simple also. You just go up that existing stairwell, drill a hole through the floor, put a 5/8" steel tube through there, and continue up. In US dollars, it's estimated that for the address building, it would take about $525,000 to retrofit that system in US dollars out of San Francisco labor market. For Dubai, I suspect the cost of retrofit will be substantially less than union pay in San Francisco, USA. Some of the future for the system, occupant survival. The chief from Chicago described occupants getting trapped in a stairwell in a chimney effect. Well, it'd be very simple. The companies in research on this, it'd be very simple to take this high pressure system, convert it to a low pressure connection, and have rescue masks on a low pressure air supply system located at various locations in the stairwell as a refuge center, for example. So if you had victims coming down that are getting trapped in smoke, they would have access to a mask to survive the event. And these could be located in numerous locations in the stairwell, and pretty inexpensive to do so. Structural collapse, pneumatic tools. Today we're in an environment with terrorism. If there's a bomb that's detonated in the building or a plane flies into the building and you have kind of a structural collapse and that sort of thing, Phoenix got started on this. It's a high pressure system. You'll operate your pneumatic tools quite nicely off of that. You just need 100 or 200 meter or foot hose to connect it up, but at least you have access to lift and move. Chemical and bio contamination, every high-rise has some level of hazardous materials. When you have your air refill supply in that neighborhood, you reduce the contamination of firefighters leaving that contaminated area, going down to lower floors, et cetera, going through a T-GON process just to get their cylinder replaced. They simply go to a location, stairwell, get topped off, and return to work. Law enforcement, active shooter stuff, law enforcement will often be wearing breathing apparatus as well, and they have access to the same system that we would and resupply their air. So, some of the benefits creates a higher level of safety and effectiveness, and I want to emphasize this. Normal procedures in a high-rise is to get a team up to that fire floor very quickly and get a hose stream in operation. And then the second wave generally starts providing the backup on air bottles. With this system, assigning those dozen people to shuttle bottles up to the upper floors now allows the incident commander to put them up on the fire floor with additional hose lines. You get more people on the firefight earlier, and you get more, a longer period of work time by using the air supply system. It's a very safe system. You're not going to have any contaminated air because it's monitored so much, but it's a very, very good system to allow folks to operate on a high-rise building at any level for a longer period of times, and reduces that burdensome process of carrying cylinders up to the top. The company's name is Rescue Air. In the U.S., there's about 400 installations or 400 communities that are using this system. So it's a very good system. I thank you very, very much, and